Hi friends, welcome to another session of Python programming. So today's topic is queue data structure. So I would like to explain the concept of a queue data structure, what is a queue and how it functions and all that. So queue is a linear data structure. What do you mean by linear data structures? The elements are arranged in a linear fashion. That means if there is one element, the second element will be after that and third element will be after that. So that is the order that they follow actually. Okay, so queue is a linear data structure which follows a particular order where the operations can be performed on queues are first one, the insert operation, which is known as the enqueue operation, and there is a delete operation which you call it as a dequeue operation, and the order we follow is called first in first out. What do you mean by insert? So if you insert an element into the queue, it is called enqueue. If you are removing one element from the queue, it is called dequeue operation. So whoever the element or the person who is entering into the queue first is the one who is leaving the queue first. So we follow the order called first in first out. Okay, now I'll show you a small animation so that will clearly explain the concept of a queue functioning. So see here, there is a milk booth and a person standing with some milk bottles. Okay, so this particular operation is called enqueue operation, that is inserting persons into the queue. Okay, so there is a first person coming into the queue, you can see that. Then I want to insert another person, so second person comes into the queue and stands next to the first one, and third person enters and fourth person enters, so on and so forth, right? So everyone is in a linear order. Okay, so this depicts the concept of enqueue operation, or you can call it as an insert operation, which is similar to the push operation in the stack, right? So now I want to show what is a dequeue operation. So dequeue means you have to remove element from the queue. Okay, so in queue actually what happens is the elements are inserted at end and the elements are deleted from the front. Okay, the end point is called rear and the starting point or beginning of the queue is called the front. Okay, so just look at this. Okay, if the first person has taken the bottle, so he will leave from the booth. So the person who is leaving is the first one who entered into the queue. So this will be like that. So the first person goes there and the queue will adjust it to that. That means each element is shifted by one position. So the second person leaves and the third person leaves, fourth person leaves, and so on and so forth. Okay, so that's called the animation. Okay, now I'll show what is this and how it will be executed. Okay, just think of this particular enqueue operation is we have taken some an empty list. Okay, so where the blue color representing index value and the gray color representing data value. So think of it, initially there are no elements in my queue, that is my queue is empty. So front and rear will be at -1. So obviously the index values of the queue will be starts with 0 and 1 and 2 and so on and so forth until the length of the length -1 of the list. But initially there are no elements, so front and rear are at -1. So now my task is I want to insert the values 23, 32, 11, 10, 5, 16 into the queue. Okay, so how I will do that? Now you can see that the element 23 entered into the list. So front is came from -1 to 0 and rear also -1 to 0 because that position 23 or index 0 is the present front and the rear. Okay, next I want to insert 32. So you have to insert a value into the queue at a rear point, so that is rear is 0, right? So 32 will enters into the index 1 and your rear becomes 1. So front will be fixed to the 0 only and rear will increment by the each value you insert into the queue. Next 11 enters into that, rear will become 2. Next 10 enters into that, rear will become 3, and 5 will enter into that, and 4 will be your rear. Okay, so that's how you can insert values into the queue. This is called enqueuing operation. Okay, if the queue is full actually, okay, if I want to enter a 16 number, okay, so there is no place in this list, so that means rare is a length of the list minus 1, so then it gives a condition called overflow condition. That means the queue is full and there is no place to insert extra elements into that. Okay, so this is called enqueue operation. So during enqueue operation we get a condition called overflow condition. And coming to the dequeue operations, okay, so take our list which is filled with all the values. So front is at 0 and rear is at 4. Now I want to remove the first element from the index 0, because that is the front, is the place where you will remove the elements. So 23 will be removed, okay, and 32 comes to the place of 23 and 11 comes to place of 32. That means each value is shifted by one position towards left. Okay, now front is always 0, but you can check here rear has decremented from 4 to 3 because there are only 4 elements, right? And if I remove another element, so rear becomes a from 3 to 2, and after that 2 to 1. So when you remove each and every element, actually rear is actually changing. Okay, when there is only single value, your front and rear both are same, that is at 0. If I emptied my queue, so your rear and front will become a -1 and there is no elements. Okay, if you try to delete element from the queue which is empty, you will get a condition called underflow condition. Okay, so this is called queue data structures. Now I'll show how to implement these queue data structures with the list concept of a Python. Here I have taken an online Python compiler or interpreter. Okay, so now I'll show you the execution part of this. Okay, how to implement this. Initially, how to create a queue. Okay, so I want to create a queue by using a list. So queue is like this. Okay, so initially queue is empty. So I want to see that whether my queue is empty or not. So print queue is okay, so you can see that queue is empty. Okay, there are no elements in the queue. Okay, now I want to perform that append operation on the queue, right? So the append operation, that enqueue operation can be performed by using the concept or the built-in method called append, where append is a built-in method which can insert a single element into the queue. Okay, so I should call queue.append and the first element. Okay, so I'm just entering some 23 or something or some random numbers. Okay, and after that I want to print again my queue, whether that appended my queue or inserted the value or not. Okay, okay, so you can see that initially the queue is empty and after appending 23, queue has become a 23. Okay, so okay, again I'll append another number. Some number 32 or something, and after that okay, so you can see that second element is entered into the queue. Okay, so in this way you can insert any number of elements. Okay, so I will just add some more elements into my queue, right? So I'll do that like this. So I'm entering the values, something like -5, and here I am entering my name, and after that I'll just print my queue. So you can see that the elements in the queue are 23, 32, -5 and Seenu. Okay, so successfully we have inserted so many elements, or Enqueue so many elements into the queue. Okay, so you can see that every time we just entered the element at end. So because the append built-in method will add the element at the back of the queue, so that is at the rear. Okay, now my task is I have to remove the element from the index 0. So here the value at index 0 is 23. Okay, so how I will do that? Okay, how I will do that is, okay, just look at this. I'll just use another method called pop. Okay, pop, and I'll mention the index value, that is a 0. Okay, and you can put this in a print method so that you can see what is the element that is dequeued. So for dequeuing, I should call that a method, that is pop method queue dot pop of 0, and after that I want to print my queue so that what exactly happened, whether that is removed or not, I want to check it. So I'm just adding that. Okay, you can see here, so element dequeued equals to 23, so that means 23 is removed, and the remaining elements in the queue are 32, -5 and Seenu. Okay, okay, so again I'm just removing the element from the index 0, and you can see what happened. And now the element dequeued is 32, and the remaining elements in the queue is -5 and Seenu. Okay, if I want to see what is the element at the front, okay, I can see that by displaying the value at index 0. Okay, so for example, I want to see the what is the element at index 0, right? So I just print element at front equals to queue of index 0. So you can see that element at front is -5, and what is the element at rear, that is Seenu. Okay, how I can print that? I can use a formula kind of a thing like this. So element at rear equals to q of, okay, the last index value can be find out by using easy method, that is len of q and -1. Okay, okay, so in this output you can see that the element at rear is a Seenu. Okay, so we successfully implemented the queue structure, the queue data structure with a list. We enqueued elements into the queue, we dequeued elements from the queue, right? And we just printed what is the value at front and what is the value at rear. Okay, so this is the sample code, my friend, how to execute or implement the data structure queue. Okay, so this is the total Okay, my friends. So this is the total code to implement the queue. Okay, hope you understood the concept. Hope this video is helpful for you. Thank you. Bye.